Hello guys, welcome to our fifth C programming tutorial. So far in our tutorial series we've learned how to do basic operations with integers, doubles, and floats. We've learned how to declare variables. We've learned how to customize our output. We've learned how to print. And we've learned generally what the main function does as well as the libraries that we draw from. So now it's time to make our first project. And I thought a good way to kind of twine these all together was to do something interesting with a temperature conversion. So I thought it'd be cool to do Fahrenheit to Kelvin. Kelvin is a temperature. If you haven't taken chemistry before, Kelvin's used everywhere in chemistry. Astronomers use it and astrophysicists use it to measure things that are very hot like stars as well as very cold. It's actually defined as the triple point of water. So triple point of water is where water is a gas, a solid, and a liquid all at the same time. So at 273.16 Kelvin and a certain pressure of water, it exists as a gas, a solid, and a liquid. And I thought that was kind of cool, just some useless trivia. So let's do a little bit of research and find an equation that'll let us convert Fahrenheit to Kelvin, because I don't know it off the top of my head. I looked it up earlier for this video though. So we'll go to Google real fast and we'll say Fahrenheit conversion factor to Kelvin. Yeah, there's the website I visited and it was pretty good, so we'll go back here. So from Fahrenheit to Kelvin. Kelvin equals Fahrenheit plus 459.67 divided by 1.8. So write this equation down or copy and paste it or something because we're going to be using it. So with that, we can go back to coding blocks and get busy. Oh, actually, let's do something first. So just to make sure that our code works in the end, they give us a neat little conversion window here that they have made. So let's type in 32.1 degrees Fahrenheit and see what the Kelvin output is. So also take note of this. So in F, 32.1 degrees equals a Kelvin value of 273.206. We'll use this as a benchmark to make sure that our program works in the end. Alright, with that, we can go back to code blocks. We're going to open a new project. Since this is going to be different and kind of its own thing from the rest of our stuff, we will do it in C. Now let's make the project title something like temp conversion or something like that. I'm just going to call mine temp conversion. And make sure that it's in the folder that you've dedicated for all of your C work so you can go back and reference it and find it quickly. So with that, we will finish the build of it and we'll go into the main function. We can actually keep these two header files as well as the main function, but we'll delete this printf for hello world. And we'll give ourselves a little bit of space, and now we're going to put back in the equation that we noted down earlier, which was Kelvin equals Fahrenheit plus 459.67 and then times, actually in the equation it was divided by 1.8. That's the same as multiplying by 5 divided by 9. So just like that, that'll work too, and that's actually what we're going to use. So looking at this equation, this will give us a good place to start. We need things, so we need variables and places to store the values that we will use to manipulate Fahrenheit and make it into Kelvin. So to start with, we're going to need a place to put our Fahrenheit value. We'll leave it uninitialized for now, and we'll make it a double. So that way we can see the temperature to the nearest decimal, and we can put in decimal temperatures, which is very useful. But we won't initialize it. We'll say double F for Fahrenheit val, and then just a semicolon. And in the same way, we're going to need a place to store our output, because the goal is to get Kelvin out of this whole thing. So double kval. Now, this takes care of two of the figures in this equation, but what about the other two? Or other three, I guess. We'll kind of group this together, the 5 divided by 9, and that'll just be one conversion factor. But the base 459.67, that's going to be unchanging. So let's do double and then base in all caps so we know never to change that or manipulate it in any way. 459.67. We'll get into constants later where we can actually declare this as something that will be unchanging, but that'll come in a later video. For now, just make your constants completely caps in the variable name. So we have a base. And now for the last figure of this equation, the 5 divided by 9. So that's a multiplier, a conversion factor. So we'll do a double in all caps, CONV for conversion, underscore fact. And we'll make this an operation declaration. So 5 divided by 9.0 and then a semicolon. Alright, great. So everything's accounted for. The Kelvin, the Fahrenheit, the base, and the conversion factor. It's all here. So that's awesome. Now let's go into our main function. And this is where commenting is going to come in handy, because you'll be able to go back and look through the body of this code and realize what we did. This is pretty straightforward, the variable declaration, but now we need to think through this. So first of all, we're going to need a place where the programmer can establish the value of Fahrenheit that he or she wants to convert to Kelvin. So let's start a comment line with a double slash, and then let's make it obvious where we're going to put this, because it's not getting user input, meaning when you run the program, you don't type in the value you want to convert after it's running, you have to put it in before. So let's make our code very readable, which is a good thing. We'll do double slash these stars, and then we'll say enter temp to convert here, and then maybe a little more, and then we'll do another double, and then just a whole line of these little shift 8 thingies, these asterisks. Alright, give us some room there just to make it readable, and we will say fval equals 0. We'll initialize the Fahrenheit value to 0. Okay, cool. So now we have a place where we can say, okay, this is the Fahrenheit value I want you to convert. So now we need an operation. So we look back up here and we'll say Kelvin, so kval equals, and then parentheses, fval plus base times CONV, and it pops up right there. So you can just, if this comes up, it saves you a lot of time when you're doing big projects. See how I said CONV, and then it popped up a window right here. You just hit enter. That will save you a lot of time, and will make you it'll make your code a lot more efficient. You'll code a lot faster for very big projects when you can just do that for longer variable names like conversion factor. Okay, cool. So now we have an operation. Let's just comment this real fast. Operation to change Fahrenheit to Kelvin. And now we need to print Fahrenheit value and also print Kelvin value. So we'll have two print statements. So the first one will say printf, and in quotes, the temp in Fahrenheit is, and then a colon. So now we're going to need to put a specifier in here, which we went over in the last tutorial. We need a specifier where we can put a double in, since the Fahrenheit value is a double, which means we're going to need to use %f. And then let's do a new line. So it divides the print statements up into two lines, and it makes the output more readable. And then we need to specify what value we want printed in this %f. To do that, we'll do a comma after the quotes, and we'll say f value. So print our Fahrenheit value in %f. And then for the second line, we'll do the same thing. So the temp in Kelvin is, and then %f, new line, and then comma, kval. All right, so this should print the temperature in Fahrenheit is, and then the value that we enter for the Fahrenheit temperature, and then this line should print the temperature in Kelvin is, and then the value that this operation gives us for Kelvin. So let's try it out and make sure that it works. But first, let's add a comment down here, and if the program does work, that means that 32.1 Fahrenheit, so if F equals 32.1, then K should equal 373.21. We'll round to the third decimal place. And that's what our website gave us. So theirs works. I've looked at a few other sites. It's the same. So that's what ours should output if it works. So now let's go ahead and run it and see if I gave us any errors. And no, I did not. And no, I did not. But it didn't output the... Oh, and no, I did not. So we haven't actually put in the correct F value yet. This was just the F value for 0. So it compiles and it executes, which is a good thing. We don't have any syntax errors, but we need to make sure that it works properly. Let's go ahead and change our output though, because we don't need to know all these decimal places. Usually temperatures, if not measured to just the whole number, are measured to only 2 decimal places. So let's go ahead, and if you remember from the last tutorial, between the percent and the F, we'll put 0.2 in both of our statements. And this just says, after 2 decimal places, I want you to stop printing my output. And also, let's go to the F value and change our temperature to 32.1. If the program works, it will output 273.21. So the moment of truth. And sure enough, 273.21. Excellent. So with that, I'll leave you with kind of an exercise for those who want it. I'll put 2 more equations down here. Fahrenheit equals Kelvin minus 459.67, and then times 9.0 divided by 5.0. And then I'll do Celsius equals Fahrenheit minus 32, and then times 5.0 divided by 9.0. So if you want some extra practice, here's a challenge for you. Go ahead and do these 2 conversions as well and print off everything. That'll give you some more good practice with working with these basic skills that we've learned so far. With that, thank you for watching this tutorial, and I hope to see you next time.